All right, next what I'd like to do is take a look at a few more examples of global wind currents. I'd like to begin with Santa Ana breezes. And so these are breezes that we are familiar with here in the western United States. And typically what we tend to get in the months leading up to the summer, but usually not including the summer, is a high pressure region offshore. And so, as we have learned before, this is the result of sinking air. And so we have, say, in the Hadley cell, a region of air which is rising up at the intertropical convergence zone, and then dropping back down in this high pressure region. And then from this point on, this tends to be at fairly high elevation. So although the air is being compressed, we can think of it as being a somewhat cool high, at least at first. And then as it comes off the Rocky Mountains, it goes downhill, and so we get some warming. As the air drops to lower elevation. And so then in our region of California, what's happening, because this is a cold high, is that we tend to not have much moisture in this air. And so this air is very dry then, and it warms up because of the heating that's experienced as the warm air mass compresses. So here, as the air compresses because of higher pressure, it heats up. But it was already dry. And so what we get then are offshore breezes here that are very warm and dry. So these tend to funnel out in the area that is usually around Los Angeles, San Diego, and to a lesser extent up where we live in San Luis Obispo. And so this then tends to give us clear weather because we have this downflowing air. So this is stable. It's not an unstable kind of a wind situation. And this increases fire danger. Particularly in an area like California where we are not getting as much rain as would be considered normal, possibly due to global climate change. We are experiencing this lack of moisture. And so if you get these hot, dry winds moving over the land, that'll absorb even more moisture and make things even drier. And so that is the main thing with the Santa Ana winds. If we go up to the data projector, we can look, and this comes from page 248, sorry, 348 in your, yeah, that was right, 248 in your textbook. This is where the high might be located. It could be quite a bit inland, or it could be closer to the west coast. But we're at a higher topographic relief, and the air is moving downward toward the southern coast of California. So associated with that, then, we can get some very dry winds, and associated with that, we can have some really, really nasty fires. And so here's a look at the Santa Ana winds as they move out in the areas around Los Angeles, are kind of funneled into this area by the topography in the area, and tend to dry out this whole area of California. Now, next thing I'd like to talk about is the monsoons, and these are also seasonal. We tend to, in India, for example, India is famous for its monsoons, and one of the reasons for trying to understand monsoons is to get a feeling for why these wind patterns change so abruptly from this very, very wet kind of a summer monsoon condition in which you get tremendous amounts of rainfall to this very dry condition which tends to happen in the winter, which we get these offshore breezes that are somewhat hot and dry, basically from high pressure region up in the Himalayas. And so the way to understand monsoons in India is to first look at the intertropical convergence zone and how that moves with time. So if we were to look at India during the summertime, the Earth is going to be tilted toward the sun, and so that's going to move the ITCZ up a little higher. The ITCZ will be up here. Now remember that this is the region in which we have low pressure, and air tends to move in toward these regions of low pressure from above and from below. But what we get here with the ITCZ moving northward is that it is then above India. Okay? And so what will tend to happen then is that air will move in and converge with the ITCZ. And as it does so, it is going to start to rise. So if we look at this thing from a side view, what we would see is that you start getting associated with this air moving up to higher elevation. Here's the Himalayas. This might be, for example, Mount Everest. And here would be India. And you'd have this slow increase in elevation as we get to the Himalayas. And so this air then moves up to higher elevation, experiences lower pressure, and starts to expand. Rise and cool. And so this gives rise then to pretty much a continuous set of showers along the entire coastland of India as it moves in toward this inner tropical continental convergence zone. So that would be your summer monsoon then. It would be associated with this flow up toward the ITCZ. which would be here. So this would be our low pressure. The air would tend to move in toward the low from the south, and then it would rise up, and it'd be forced up by higher elevation, but it's being drawn toward the low, and so as it's forced up, the clouds become unstable, they cool, and this generates the rain. So that's the summer monsoon in India. And so what happens then in the winter? Okay. Well, if this is the summer, remember that the Earth's leaning toward the sun, so that means that the direct sunlight is hitting higher up in the northern hemisphere during our summer. And so in the winter time, then the ITCZ moves back down toward the equator. And so, again, here would be India. But now, we expect the ITCZ to be down here somewhere. It's moved down in the wintertime. And so now, the air that is moving toward the ITCZ from the north is going to move off of the Himalayas. So this will tend to be a high pressure region here along the ITCZ, which is our kind of like our equator for the convergence of warm air that's coming not only from the northern hemisphere, but also from the southern hemisphere. It's going to result in offshore breezes, like what we saw before with the Santa Ana conditions. And so here then, you would expect a cool high at high altitude. So the air then would tend to converge there, much like it did with our Santa Ana conditions in the western United States. Then it goes downhill. There's some heating. And we get the offshore flow. Which tends to be fairly dry air. That's been warmed somewhat by dropping down in elevation from higher elevation to lower elevation. So the key factor here is the motion of the intertropical convergence zone up to here, which creates the onshore flow, causes the air to rise, cool, generates the cumulonimbus clouds, the unstable clouds, which tend to drop their moisture quickly. And that gives us our summer monsoons, and then here we get our offshore breezes during the winter. It's associated with our winter monsoon. Okay, so we can take one more look at our map up here. We can see what's happening then in the winter time. We tend to get this very dry air that flows out from this high up in Tibet, the Tibetan Plateau, and the Himalayas. And that's associated with the inner tropical convergence zone being down here. But then in the summertime, the intertropical convergence zone moves up to here, and then the air moves up toward it. And then the moist air, which is coming off of the Indian Ocean, is then rapidly raised to higher elevation, creating unstable clouds and lots of monsoonal airflow. We get a little bit of the monsoonal conditions in the eastern United States, to a certain extent in the western United States. This is California and Mexico here, and then this is Florida, let's say, like that. We can get some flow of moist air, which happens when we have associated with a tropical low that has moved up during the summer. So associated with that, then, we can get some monsoonal flow, not only from the airflow that has come directly off of the Gulf of Mexico here, but also to a lesser extent by air which has moved out over the Pacific and then can kind of do a glancing blow to places like New Mexico. So that can get a little bit of this monsoonal flow that's come up from the Gulf of California, and can mix in with some of this other monsoonal air, which is then being attracted toward this low in the middle and eastern United States. We can also, in the Great Lakes regions, get lake effect snow. And so this is something that often happens in October, November, and December, where you have a large lake, one of the Great Lakes, like for example, this might be Lake Michigan. And then you get evaporation off of the lake. But what will happen with lake effect snow is that you can get some very cold Arctic air moving over. So the cold Arctic air moves over, and then the evaporating water is cooled rapidly to form snow. And so one of the football games a week or two ago, the Buffalo game, was moved to a different location because there was 5 feet of snow in one evening. And so this is the kind of thing that can happen then when you have this source of moisture, but then you have this unusually cold Arctic air moving in, and then this air super cools the water, makes snow. And from this ready supply of moisture, which is then super cooled, you get tremendous amounts of snowfall. In the vicinity around the Great Lakes regions.